blocks that we spoke about last time, put them into practice here and give you kind of an idea of how they work and what they do. What I want you guys to do is just kind of pay attention to what I'm doing and not necessarily try to memorize the coding that I'm doing. I want you to understand the concepts. Eventually down the line, we'll get to a point where I help you set up your environment, and we'll do some live coding and maybe have a project that we all do together. But for now, I want you to pay close attention to what I'm doing and understand the concepts, because that's the biggest thing. Like I said, you understand the concepts and you can actually translate those concepts from language to language and better learn languages. So we'll start with data types. Like I said before, data types are a way of describing what type of thing this is, right? So we have our strings. A string is essentially a bunch of characters in between two quotes, or one quote in some cases. It can hold as many characters as you want to put in it, most of the time, and it doesn't really matter what you put in it. Essentially, it's a way to store any amount of characters that you care about. Then we have something called a number, or an integer, or float, or a double, or any of those things. That's the way to describe what these numbers are here. So you can also store numbers. It doesn't really matter. There are some limits in some languages to specific data types, but for the most part, you just kind of deal with numbers. You need a way to store numbers, right? And then we have things called arrays, which they actually help kind of store some of these smaller values. Oh, yes, and Booleans. Booleans are important. Booleans are actually just binary values, true or false. They're used in a lot of different cases, but they're useful and they're simple. Now we have this array that we talked about, which stores these smaller values. So you can have an array with strings. You can have an array with numbers, like we described. You can have an array with Booleans, like we just described. True, true, false. It doesn't really care, especially in dynamically typed language. You can kind of just put whatever you want in it without many limitations. Now remember, when I spoke about dynamically typed versus statically typed, essentially all that means is it loosely cares about what data type you're dealing with. So now if we take what we learned here, our data types, and we move into some variables, we can actually assign these to some variables, and that way we can use them a little bit later on in this file here. So JavaScript is what I'm using right now. It is a dynamically typed language, so it doesn't really necessarily care about the data type that you have, like I just said, and it really only cares if the value can change. So it has two ways of what they call instantiating a variable. So I can call this just like random letters and equals that. Like I said, coding is built around these logical constructs. They're essentially just building blocks to get you to a point of creating a program in a logical manner. They're not terms to memorize or anything like that. So on to the next thing. Like I said, JavaScript only cares about whether or not a value changes. So we have let, which says that right now it's this value. Right now this name is this value, but it could change. And then we have something called const for a constant. And this says that this value should not change. It'll actually give you an error if you try to change it after you instantiate this value. So we'll call this one other random letters. And then we can just go real quick on this. We can call this one my favorite number. Okay, so now we move on to logical operators. Logical operators is essentially how you compare two variables' values. So typically you would compare strings with equals, or you would try to see if one string includes another string, or something along those lines with strings. With numbers, you would compare value, obviously, because there's not much else to compare. With Booleans, you would just see if they equal each other or not. So here we can now compare things. So we can say, hey, does this random letters equals other random letters? If it does, then we can do something. So this would mean that these two strings are exactly alike, which is not the case. So it would return a false. So anytime you do a logical operator to compare two things, it'll return true or false, which is part of where Booleans come in. So you can compare in that way. You can also compare, and you can say not equals. And just like I said before, that all these languages are comprised of logical constructs. So up here we already used equals, right? So down here, when we're comparing two things, we can't just say they equal each other. We have to add some characters to that, or we would have to use something else that may not have made sense. It actually made more sense to the person who developed JavaScript to add 3 equals than to come up with a different way to put that together. And the same thing goes for this not equal. So now we want to compare numbers maybe. So we want to know if my favorite number is greater than my age. So we would say something like this. Is my favorite number greater than my age? And this would probably return a true, right? So then we can also compare to Booleans. So does some Boolean equals some other Boolean? So now we can actually put these things inside of if-else conditions. So it is exactly what it sounds like. An if-else condition would take this here, and you put it in here, and then if that's true, it'll execute anything between these two curly braces. In this case, like I said, don't worry about syntax right now. Don't worry about how everything is being put together. Worry about the concepts with me right now. So this, in most cases, is referred to as a block of code. So if this is true, it's going to execute this block of code. So then you could do something like change my age to 12. So then you can actually expound on that. You can say else if, and we can go here, if my favorite number is greater than my age, then we can make my age equal to my favorite number if we want. Oh, favorite number. Yes, you can do this. So like I said, this is all around moving data. An application is about moving data within a computer, right? So we have data types, which say what type of data that data is. We have variables, which give a name to that data, and now we can reference that data. So doing this is referencing the value of favorite number. So then we can move into loops, which is why I waited on going any further with arrays. So now we have a loop, and again, don't worry about the syntax, just worry about the concepts. So we have a string array, right? And so for every value, or for every string of this array, we're going to do something. So what we did here is essentially we're creating a variable for each value within the string array, and this for loop, as they call it, would go through each of these values one by one. So it executes this block of code for each value inside of this array. So here we've called this a string. So we'll say if string is here, then we can, I don't know, set random letters equal to string. So it'll do that. So the first time it'll go through, it'll set random letters to tie. The second time it'll set random letters to 12, the string 12, not the number. So you can do that as well, and you can do that for any array that we have. Then we have something called an object. I waited on this because it's slightly more complicated than all of these. It kind of puts them all together. So an object in JavaScript is that. This is actually just an object. So don't be confused. Again, I'm reiterating. I want to pound this in. Focus on the concepts. Every language has objects. Objects are quintessential to every language. What they allow you to do is create something to describe something in the world. So now that we have an object, let's say that we have a person object. So this object should describe that person in whatever way you care to describe a person. So we can say person dot. We're creating fields within this object. Person dot age equals my age. We can say person dot favorite number. Favorite number is favorite number. So what this turns out to be is exactly this. So we'll say the person equals, and I'm going to open this up just so it's easier to understand. Age is my age, and favorite number is favorite number. Just like that. So it doesn't really matter if they're uppercase or lowercase, technically. There are best practices throughout any language and throughout coding in general, but just keep in mind what's happening here. So the age essentially would be the same as writing 1, and then the favorite number would be this weird thing. And that's kind of how that works. So you essentially are describing what a person is. At this point, all this object describes is the person having an age, and it has a favorite number, and that's it. So all of this logic could actually be used to populate who a person is if you wanted it to, and if your application was purposed to do that. It's very useful, and you use it all the time. That's what you're doing. You're moving data in one way or another. So now we have I/O operations. I'll just describe those. They get a little bit more complicated here and there. Essentially, this would allow me to take this person, if I wanted to, and write them to a file or read them from a file. Very useful. And then we have syntax. So I've referenced it a couple times while we've been talking today, and I've referenced it in previous videos. This is just the way a language puts these different things together. This is JavaScript, so this looks this way because of the foundations of how JavaScript was created. It's written this way. So now that we understand all of this, functions come in. They're another keyword within JavaScript. You can't you don't want to create anything called function because it's a keyword. This program actually does a lot of thinking for me and helps me pick up errors before they happen later on when I'm running my program. But see, I can see this error. I'm trying to use function to set some value, and that's not okay because that's a keyword. So that's one of very few limitations when it comes to the naming conventions of your variable. So we have a function, we give it a name. So it's very similar to how we create a variable. We have a keyword to start with, and then we move on from there. So I can call some function get my age, and I'm writing it like this so it's easier to read. See, it looks a lot like a if statement, except it has a reference to it, much like a variable, right? You can actually reference this function later on in your application in one way or another and get your age if you wanted to. So we would do this, and you can do something called return. And what that does is when you call this function, when I call this function, it'll return something. So in this case, I want to return my age. and it could change because of this logic we've used somewhere in the application. And then we could even set a variable to it. Let my person's, oops, don't do that. Person's age equal get my age, and that would actually return this age, which is up here. So as you see, it's getting a little bit more complicated, but it's still pretty simple conceptually, right? You understand the concepts now. So now we're going to jump into syntactical sugar. Syntactical sugar is just a simpler way to write a language, or sorry, not a language, a piece of code. So you can actually write a function in JavaScript like this if you'd like, const or let, it doesn't matter. Give it a name. I could call it get my other age, and then you just give it something called an arrow function, and this would be how you would return my age. So this would return the same thing as this returns. You can even shorten it more with syntactical sugar. You don't even need a return if it's like this. And yes, it's shorter, but if you're unfamiliar with the language, don't be afraid to do this. That's fine. This is when you kind of understand it and you need to write a little quicker. That's completely okay, and that's where language familiarity comes in. So when you're familiar with the language, you're familiar with the concepts, you can write these things a little bit more without thinking about them, which is a big help, because then you can just kind of think about the rules around what you need to do rather than how you're going to code it. You can think more about what the outcome of this should be more than the concepts within all of this. And there's one last thing that I want to mention. So function can do more than just return something. You can actually encapsulate an entire block of code within this function. So you can have something like this within it. It goes the same for loops, it goes the same for ifs, but the power of a function is you actually have a name so you can reference it later, which is pretty awesome. And that's kind of all I have for this video. I really want you to get these concepts. Don't be afraid to just do a little reading. You don't have to code to understand. A lot of my understanding has come from just kind of reading about code. And when you put it into practice, that kind of helps set it in stone. But just because you're not coding, it doesn't mean you don't understand it. We'll move into coding probably somewhere in the next couple videos. And I hope this helps you. Let me know what I can do better. Let me know what else you need. Go ahead and put it in the comments, like, subscribe, and I'll talk to you soon.